Okay, so according to the National Center for Health Statistics, 22.4% of adults are smokers. In a random sample of 300 adults, determine the probability that fewer than 17% smoked, and B, in a random sample of 300 adults, determine the probability that at least 50 were smokers. So we're being asked to do a probability, which makes me look at that formula sheet and say it's got to be one of the top three, because that's where probability lies. And we're looking at probabilities now in terms of percents instead of looking in terms of means. We're looking, what's the probability that a percentage smoked? So that tells me we're doing the sample of 300. We want a probability. We have a sample, n equals 300. And in the population, we're given a proportion or a percent of P equals 224%. Oh, sorry, 22.4%, which is 0.224. That tells me we're doing the probability about a sample proportion, because they did a sample of 300 and want to know the probability is fewer than 17%. So that means we're looking for the probability that P hat is less than 0.17. Any questions on how I knew how to do that?
When you have any sort of percentage, is it something where you'd want to find the population sort of idea?
Yeah, if we have a percentage and we're looking for a probability about a sample, then we're going to do it this way.
Okay.
So it's looking for the word sample and probability, which tells us it's either a mean or a proportion. And there's nothing about the mean here. And it's all about percents. So that helps you know. So I look at the formula sheet, which says how to tell if it's normal. So the first thing we have to do is test if our distribution is normal, just in case you have to do that. So those are called our initial conditions. So we need to know that n times p times 1 minus p is greater than or equal to 10. So n is our sample size of 300. P is our 0.224. If you calculate 1 minus p, it's the opposite of 22.4%. So it's 0.776. So either you can do that in your head or you can calculate it. When you add those together, you should get 1. When you multiply those three numbers together, you get 52. So that's definitely bigger than 10, which means we do have a normal distribution. Okay, and what does that normal distribution look like? Well, mu sub p hat is the same as p. Remember, p is the population proportion or percent. So that's going to be 22.4% or 0.224. Sigma p hat is equal to the big square root of p times 1 minus p over n. I talked to a few people who've been having trouble calculating this. So if you want to practice calculating right now and make sure you get what I get, it's a good idea. So we're going to do the square root. I'll go over here. Of 0.224 times 0.776 divided by 300. If you have a calculator where you put the number in first and then hit the square root button, go ahead and do this whole calculation first and then hit the square root button. If you have a calculator with a square root and then you put the number in, then you want to do the square root and then a parentheses to say first multiply all this stuff together and then close the parentheses. So it depends which kind of calculator you have. That's why I'm asking you to check. If you do the square root first, go ahead and do the square root, but put everything in and then hit equals and do the parentheses. If you put the number in first, you can go ahead and do the calculation first and then hit the square root button. But your answer should be, and we're going to use 6 decimal points here in order to get the right calculation, is 0.024071. Any questions? If you're having trouble with the square root, I can definitely help you with that. I've had people like show me their calculator on Zoom and I helped them out, so don't worry about that. Okay, so we have a new sigma and a new mean and a probability, so we go into StatCrunch. I'm going to go ahead and do this one with StatCrunch. So our new mean is 0.224. Our new standard deviation is 0.024071. And we want the probability that our p hat is less than or equal to 0.17. So we get 0.01243 and round to 0.0124. Any questions? Awesome. All right, so I'll go back. Let's look at the second question. It's also a random sample of 300 adults, so we don't have to test again. We know it's normal. And we're determining the probability that at least 50 were smokers. So we'll use the same information from here, that we are using the p hat distribution, which is normal because of NP, 1 minus p is greater than 10. And we have mu sub p hat, our mean, is equal to p, which is God, I'm blanking out, 224. And our sigma p hat is equal to the big square root, and it's the same from before, 0.024071. And we're asked for the probability that at least 50 were smokers. Probability that we have at least 50, so x greater than 50. Now notice 50 is very different than 0.224 in terms of the size of the number. If you put it in StatCrunch, you're going to get the answer of 0, and it's going to look really weird. It's not even going to show up on the graph. That's because we need this to be translated into a p hat probability. So we're going to do the probability x is greater than 50 divided by the sample size of 300. Then that's going to be the probability that x is greater than 0.16666, and I'll round to 0.167. 0.167 looks much better than 0.224. Does that make sense? Okay, I think I might have done it wrong on the answer sheet. I think I did a less than instead of a greater than. So I'm going to go ahead and calculate this to check. So I'm going to be using 0.167 with StatCrunch. So going back to the StatCrunch, we have to change this to a greater than and 0.167 and compute. And we get 0.9911. So mine is backwards on the answer sheet. Change that to 0.9911. And I'll upload the answer sheet when we're done to the new one. Any questions on that? Okay, so going back. Too many pens around. There we go. So our answer is now I can't remember, 9911. So almost 100%. Let's look at that at least 50 were smokers idea. So again, when you're looking at the distribution, we're talking about 0.224 as our mean. Our standard deviation is about 0.01. So it'd be 0.22234, 0.244, etc. So over here, it's going to be 0.254. So 50 is way out there. It's off the page. And that's what tells you need to do this. This is a distribution of all the proportions, all different sample proportions. So if we had a sample of 300, at least 50 were smokers, we need to think of it in terms of the proportion and not the individual data. Does that make sense? Any questions on this?